Hi guys, it's Richardlizhu, and today I'll show you how I use my computer science skills to create the best Wordle bot. Let's get started. For those of you who don't know, Wordle is a game where you have 6 chances to guess a 5-letter word, and you get 1 every day, and it's the same for everyone. So here's the bot that I've written. So it's actually already told me, I actually just ran it for today's word, and it just told me that the word is vivid, and it got it in 4 tries. So the first word to always guess is soar, is the best word for my algorithm, is the best word for any algorithm. It's the best starting word. And some people come to this conclusion differently. A lot of people create Wordle bots, but a lot of them are like very simple. So I had first seen Wordle, through a lot of news sites, and the backstory was like, I'd seen it, but then my girlfriend one day was like, "Hey, have you heard of Wordle?" Because she had just started playing it, and she challenged me basically to Wordle, and I thought, I'm a smart guy, I can do Wordle, but after I tried, I just couldn't beat her. Like, I would sometimes match her, but I would usually get worse than her. Maybe once or twice I would get better than her. And so like I was getting frustrated, and I was starting to think that my girlfriend thought I was dumb, right? So in order to beat her at Wordle, I created my own bot. I used my skills, I used what I'm good at, computer science, in order to program a bot in order to beat her at Wordle. My bot has always gotten the word for me in 3 or 4 guesses, and it's never taken more than that, and it usually gets it in 3. Today's word was pretty hard, so it took 4 guesses, but let me take you through. So the first guess it tells me to make is soar, right? I ran the algorithm once, and so unfortunately today we see that there are no matches. So this is kind of like the least information that we're going to get. So we see from the program, we input a 0 when there's no matches at all, and then we input a 1 when it's a yellow tile, and we input a 2 when it's a green tile. By having all zeros, we narrow it down from like 2,000 possible words down to 162 possible words. So then it tells us to guess punty. So we guess punty, and again we get the least possible information. This cuts it down from 162 words down to 11 words. So in order to get the most information now, we guess the word child. And now we finally get some useful information. So we get that I, the third letter, is somewhere in the word, and then the last letter D is in the correct position. So now it tells us that there's only one possible word, and that word is vivid. And so yeah, V is a very uncommon letter, and then vivid also has like 2 repeating letters, so it's very difficult to guess. I'm actually quite curious to see how my girlfriend did for this word. Let me kind of take you through the setup and the algorithm. So how Wordle is set up is that this is the set of like 12,972 5-letter words that you can use as possible guesses. And then of these, actually only 2,315 are possible words that can actually possibly be the answer. So this was actually gotten through mining the code of Wordle, and I didn't do this. I found someone else had done it, so I decided to leverage their work. And then up until now, there have been no repeats for words. So now here's a running list of all 248 of the previous used words, all the words that have been used before. What I do is I go through this document, the 2,300 answers, and I eliminate all the words that have been used before. Obviously, at some point they're going to have to start repeating, but they haven't done it yet. So let's bring you through my code. So I kind of use this as a coding exercise for myself. I kind of tried to use a lot of these data structures when it's possibly not necessary to use so many different ones. Like, as you can see, I use array lists, tree maps, hash maps, linked hash sets, hash maps, pretty much the whole 9 yards here. So I decided to write in Java because that's kind of the language that I would use for like an interview, right? So I decided to brush up on my Java skills. Python is probably the language that like most people would use, but I wanted to exercise my Java chops, so I decided to pick Java. I created a structure called a Wordle, and this basically scans in the files, and we have like an array list of answers, guesses, and used words. So basically, in our main function here, we create the new Wordle just to scan in everything. So the functions that I kind of created are kind of listed here, but we have like process, best guess, sample answer, make guess, first guess, test guess, and count letters. I basically started from bottom to top, because as you type it goes down. So I started with count letters. This basically, I was just curious as to the distribution of the different letters that are present within the answers. This actually gave me some cool insights. It's very well known that E is kind of the most common letter in the English alphabet. But actually, if you run count letters here, if we do wordle.countletters, we have it right here. So for Java, you actually have to compile, which is kind of a pain, but that's the constraint of the language. So then we compile it and then we can run it. I actually forget what count letters does. So we need to actually print again after. So let's compile it again. And so here is what we output. Basically, for every letter, this is the number of occurrences of that letter, and then this one is actually the number of unique words containing that letter. So for example, if a word has 2 A's, it'll get counted twice here, but only once here. So one interesting thing to note is A is actually more common than E. How this is because in English, we're frequency weighted. Words like the, or he, me, these words with E's in them get used a lot more than words with A in them. But when you look at the set of 5-letter words that is not usage weighted, we see that A is actually the most common letter. So I've seen Wordle strategies that just like look at this map and just be like, A is the most common letter, and then it's probably I is up here, R is up here, O is up here, all the vowels obviously. So then they would come up with a strategy. E is the second most, obviously. So they would come up with a strategy. The very naive strategy would just guess something like audio, right? Audio is a good guess. It has four vowels, right? Yeah, they would just look at this, and then a more advanced algorithm would look at this, maybe the number of unique ones. And then, I've seen algorithms which take into account the actual result that we get. So then, like, if you get it at the right place, maybe I saw one that gave a green tile gave 3 points, a yellow tile gave 2 points, and a black tile gave 1 point, right? Because when it's giving you a black tile, you're actually getting information. So you know that S, O, R, and E are not actually present in your final answer, right? It's not like these go to waste. You're getting information here. So I already know that I can eliminate these 10 letters. But what we're going to do is we're actually going to take it to kind of the extreme, right? We're going to basically use information theory to pick the answers which give us the most information, right? So in expected value, how many answers are we going to eliminate from how many answers are we going to eliminate using using each consecutive word, right? So at the end, I'm going to tell you how I can see to make this Wordle strategy even better. There are some things that I choose to optimize for. I don't optimize for the worst case scenario. Like there could be, in an adversarial case, if someone was trying to pick the worst possible word for me, this obviously could go badly because I don't try to minimize the worst case. I just go for the best expected value case, right? So now back to my code. I'll take you over the functions. It's been a while since I wrote this. I wrote this in one afternoon, basically. And let's see. So this is my test guess function. Basically, when I make a guess, it'll tell me whether, like, what the answer should be. So basically, it's simulating the functionality of the game that we have. So like when I guess soar, it would tell me 0, 0, 0, 0, and it would basically return this array, this set of 5 numbers that represents, where I hit. And then I have this function called first guess, and this is a big part of the meat of the code. So we have first guess and we have best guess are the kind of the two big functions that matter for us. So the algorithm for first guess and best guess are kind of the exact same, but first guess is more optimized for the first word. So first guess, I only called it one time, basically just to figure out the best starting word, right? Because every day of Wordle you start with the same blank slate, so the best word every day to start is going to be the same, right? So I only needed to run the function one time in order to get that best word. Running this function took like maybe 20 minutes because it's basically cubic operation. So I have a for loop through guesses, which is there are 20,000 possible guesses, and then I for loop through answers, which is then 2,000 more, and then I for loop through answers again. So if there are 2,000 answers, then that's 4 million right there, and then times 20,000 guesses, which means I'm doing a total of 80 billion operations. So yeah, 80 billion operations, basically 80 billion iterations through this loop. And so this is kind of just at the edge of tractability. Yeah, this is a brute force method, and there are definitely better ways of doing it, but basically what I do is, I go through each of the guesses and pretend like that is the word that I guessed, right? And then I go through each of the answers and pretend like that would have been the answer. And then I call the test guess function in order to say, if this word was the answer, what would have been the result? Then for each of the remaining answers, I check to see if the result would have eliminated that word. And so this is kind of to do all that calculation. It's a lot more complex kind of than I'm explaining it, because there are a lot of different cases and stuff like that. But basically at the end, we calculate something called information entropy. Basically the amount of information gain that we get from making our guess. So this is probabilistic. Basically for each of the 20,000 initial guesses, there are going to be 2,000 different entropies, 2,000 different possible entropies. So we basically take the average entropy over all of those 2,000 and find the first word with the best average entropy, and that turns out to be SOAR. SOARE. So there have been a couple algorithms that I saw online which actually come up with this answer as well. So this kind of corroborates that I'm on the right track. And I do a couple of things here to kind of speed it up a little bit. I short circuit it here. Basically, if the entropy is already greater than the average, the total, then I just exit. Then I calculate the entropies, and then I return the best guess. All right. Pretty simple. This make guess function is I actually go ahead and make the guess. So for here, after I have this hits array, so as you can see, I taken the guess and then I taken the hits. So here I put in SOAR and the hits. So I then go ahead and actually make the guess. So this is the function that eliminates the answers down from like 2315 down to 162. So what it does is it goes through each of the possible answers and it sees if it matches the hits array. And if it doesn't match, then I eliminate that word. Then we have the sample answer function. Basically what this does is this is just this loop of 5 here, basically asking what the result was. And then I put it into the hits array basically. And then now this best guess, this is the meat of the function. So it's pretty much the exact same thing as the first guess, it's a little bit different just because we take in different inputs. Basically, it's a lot faster because instead of doing 80 billion operations, we still loop over the answer times the answer and the guesses. So this is 20,000 guesses, and then we have and times the answer times the answer. So but here it's going to be like 162, right? So if we do 162 times 162 times 23,000. So this is actually not even 4 million operations. So this takes less than like 2 minutes to run. Yeah, I can actually just show you right now. If we comment out, but so then we compile it and then we call. So we go soar and then 1, 2, 3, 4, 5. We've generated the possible words, and now we're waiting for it to run those 4 million calculations in order to give us the next best guess. So it kind of does the same thing where we calculate the entropy for each of the guesses. We assume if one of those answers, one of the remaining 162 is the right answer, and then we eliminate the other ones, and then we calculate how much information gain we have, and then we do the average over all of them. And so, yeah, another thing where this could possibly be optimized a little bit more, if you do have a lot more computing power, then you could go deeper, right? Basically, I go one step deep. What you could do is you could look 2 steps deep, 3 steps, you can look even further. And if you do it in this brute force way, you will run into tractability issues, unless you have a supercomputer. But there are definitely other ways to do it. So now, yeah, you saw how long it took. It told me to guess punty. So that's kind of the best guess array. I've already gone through the meat of the function, and then now we have a process here. And process is actually kind of a helper function that runs right before make guess. Basically, I know which characters are going to be in the final one, I know which ones aren't going to be in the final one, and then I have like position mappings for all of these. And so this kind of just pre-processes that so that I can use it better in the make guess function. This is kind of a tour of what I wrote up in an afternoon to basically beat my girlfriend at Wordle. So thanks for watching this video. Yeah, if you're interested in more computer science videos, please let me know. I mean, I'm like trying to branch out, figure out what kind of content I want to put on YouTube. I've been putting a lot of kind of random stuff. So let me know if you guys like this. I will also link my GitHub below if you guys want to check out this bot. And thanks for watching this video, and I'll see you guys in the next one. Bye.